Hi, welcome to the channel Coder's Arc, where we unravel the world of coding and architecture together. And in today's video, it's a two-part series. The second part is how knowledge graphs and ontology work together. I've done a video in the past where I've introduced you to ontology and hopefully understand the core concepts of ontology like subject, predicate, object, resource description frameworks. What is the structure of an OWL file? I've covered that in detail so you understand core concepts like entities, instances, data attributes, object attributes, constraints, axioms, and relationships. I've even explained how data without ontology is like dictionary without definitions. So hopefully you understand those core concepts. In this video, I will explain how knowledge graphs are constructed using the rules that are defined in the ontology files to get precise, meaningful knowledge graphs. And when you're asking questions, you're going to get more precise outcomes, more precise answers, and some hidden things that are not necessarily visible through regular RAG architecture. You're going to be able to get multi-hop reasoning, complex reasoning easily through knowledge graphs that have been generated using ontology. So without any further delay, let's get right into it. So the first step is that the subject matter experts are the ones that will create the ontology web language files. These I've covered in the previous video are users like subject matter experts, solution consultants, industry experts, sales, marketing, developers, offering managers, product teams. These are the people who understand the domain, and usually it's a combination of them working to create these rule files. So once that is done, then the developers and infrastructure engineers are the ones that will create the pipeline. Remember, the goal in this is to create a very precise knowledge graph, not a knowledge graph that has been created without any rules. So the first thing that the developers and infrastructure engineers work together to do is create a backend API job that will reference the ontology. So developers are going to write the Python code, and infrastructure engineers are going to provide access to the repositories where the unstructured documents are so that the developers can access them. Then, following the principle of RAG, you are going to chunk these unstructured documents, and then instead of directly passing and getting the entities from them, you are going to extract the entities and relationships from each chunk using the schema, the resource description framework schema that is defined in the ontology web language files above, and you will ask the LLM to produce the structured output. I will show all of this to you, but the goal here is to create a precise knowledge graph using Neo4j that will construct the graph from nodes and edges by semantic merging, and this will be honoring all of the rules that are defined in the OWL files. So finally, once the outcome is generated, which is the knowledge graph, a precise knowledge graph, now you're going to ask questions from this knowledge graph. So now let's say you have a product and there are end users, customers who are going to be querying this knowledge graph. So they will ask a question in a natural language. For example, which medication was prescribed to John? And instead of directly asking like in a RAG, you are going to first query the LLM with the question to extract the relevant entities. So these entities in the question will be the entities that are defined also in the OWL files. So once you do that, you're going to make another call. You're going to first find the nodes in the knowledge graph that are semantically similar to the extracted nodes from the question. So you're not just going to assume, you're going to get a very precise outcome. So that's why this step is really, really important, that you want to pass the nodes in the question that are semantically similar to the nodes in the graph. And then you find those, and then and this can be done using the cipher queries. Once you do that, then you're going to pass these nodes and edges as context to the LLM along with the question to get a good precise outcome, good precise answer. So hopefully you understand this workflow. It's unlike regular RAG where you are hoping to get the right answer. With knowledge graph and ontology working together, you have eliminated the hope and you're always going to get a very precise outcome. And also one of the very key important things is that you will be able to get multi-hop reasoning, which is almost never possible with regular RAG. So hopefully this makes sense to you. I want to very briefly cover the RDF lib that is used for parsing. So the first thing that you have is a OWL file, which is an XML file, which has a resource description framework, definition of all the classes, instances, object attributes, data attribute, constraints, axioms, and other relationships. And then there is a method inside this, which is called rdflib.graph.parse, which loads all the triples into the memory. So there are specific calls where you can define the RDF type and then the OWL class, object property, a data type property to extract the entity type names, relationship names, or the attribute names. Once you've done that, the key next step is that you're going to generate the extraction prompt. This is very important because the goal for you is that you want the LLM to generate the knowledge graph, not just some random way. You want it to follow the rules that are defined in the ontology file. So you are going to first, in the context of the prompt, you're going to define what the schema would look like, of course in the natural language, which is done by parsing the rdflib.graph.parse, and then you're going to pass the actual unstructured document and its chunks, so that once you're constructing the knowledge graph, it is constructed very precisely using the ontology rules. And then obviously in my example I've used the Claude through the Bedrock. You can use any LLM. And then finally you use the Neo4j knowledge graph to construct the graph as well as query and parse the graph. So the nodes and edges are created dynamically from the ontology types. I want to very briefly show you what the knowledge graph looks in Neo4j after it has followed the rules defined in the ontology files to create the knowledge graph. If, let's say, the rules inside the ontology files were not followed, you'd probably get more entities, maybe more entities that were similar in meaning, and it would be somewhat of a hallucinated knowledge graph. That's why it's very important that when you're trying to generate a knowledge graph, you use ontology so that it honors those rules and reduce the number of relationships, number of edges in the knowledge graph. Again, I think you can parse that. You can use your own data to create the knowledge graph, but this one shows the entities inside the circles, and then the relationships between those entities are defined by the arrows. I want anybody who's watching this video to truly understand what is going behind the scenes. So what I've done is I've created a log file that shows the request that is made to the LLM and the response that is received from the LLM. No video is going to go in this level of detail. I truly want you to understand what's going on behind the scenes. So let's take a much closer look at it. So this log file first is going to show you what kind of a request is sent over to the LLM. So if you remember, I said the rdf lib Python library is responsible for parsing and extracting the classes, which is the entities, and the relationships. This is done so that you can get a natural language description of classes. For example, in my code or in my ontology file, the OWL XML files, these are the entities: patient, physician, medication, prescription, condition. And then these are the descriptions of those: a person receiving medical care, and so on and so forth. So now you, using the rdf lib, defined all the classes from parsing the OWL files, and you've done the same for relationships. You've parsed all the different relationships that are defined in the OWL files, but you've extracted only the natural language descriptions. And this is so that large language models work better with natural language instead of somewhat of a structured XML input, right? So you're trying to make the LLM get a better response. So now that's the first thing. Then you have also passed the unstructured document. So this is my unstructured document. If you remember, this is explaining what was the condition: John Doe, who's a 45 years old patient, date of visit, and then these are some medical notes. I'm not going to show you what those are, but this is like massive. These can be massive documents, right? And these are the ones that get chunked and sent over to the LLM. I'm not going to show you the chunks. I'm just explaining that these are the unstructured documents that are passed to the LLM. So two things are passed. One, the classes, relationships, and constraints, and second is the unstructured text. And now the LLM is constructed knowing this context. Please generate the valid JSON entities and relationship arrays so that I can construct the knowledge graph from them, because knowledge graphs that you saw in the Neo4j, they are structured outputs. So you cannot just get some natural language output, right? You want a structured output. So that's what the LLM responds back with. So LLM is able to semantically look at the context provided from the OWL files, as well as the context that is provided from the real unstructured text, and then construct the entities and relationships, because that's what the true power of LLMs is, that they can understand the semantic meanings. And once you get the JSON response containing entities, as you can see over here, and then scroll down, and then you can see the relationships, then using the Neo4j libraries, you can construct the Neo4j knowledge graphs. So hopefully you understand how the knowledge graph is constructed. Next, I'm going to show you a log file of how you query that knowledge graph so you get very precise outcomes. Again, I'm going to show you what kind of calls are made to the LLM so that this concept really sticks with you. Again, nobody is explaining in this level of detail, so hopefully you're following and it's making sense to you. Now, let's take a much closer look at how the knowledge graph retrieval works when you ask a question like, what medication was prescribed? Again, the question is pretty straightforward. What medication was prescribed? So using the ontology rules, you're going to extract the entities that are hidden within this question and the relationships that are being asked about. So the LLM is smart enough to be able to do that. And it's going to find the semantically similar nodes and relationships. Again, I think my example is very, very simple. So it's going to return all the nodes are semantically similar. But imagine a knowledge graph that is massive, maybe hundreds of thousands of nodes, and then your job becomes much simpler because you only get the nodes that are semantically similar to the question that you're asking. Once you do that, then the LLM has the right nodes, the right relationships, and the question, and it will be able to give you the exact outcome by following the rules of the knowledge graph. So for example, if you ask a question, what medication was prescribed, the answer you're going to get is something like this. Based on the medical knowledge graph, lisinopril was prescribed, and then it will have the medication details, prescription information, clinical context. Again, it does this by looking at the knowledge graph, by using the nodes that were semantically similar to the question that was being asked. Again, there are some other concepts like communities and community summaries. I'm not going to cover that in this video. Here, I'm just trying to explain the concept of how when you ask a question, how when you query a knowledge graph, you get very precise answer. So hopefully you found the content in this video useful. If you did, please hit the subscribe and like button. I hope now you truly understand what knowledge graph is, what ontology is, how you can get meaningful outcomes when you use knowledge graphs, ontology, and retrieval augmented generation using graphs together, and how this is more superior technique compared to the regular retrieval augmented generation process that I've covered in the many videos before. Hopefully you found this content useful. Please hit subscribe and like, and goodbye for now.